This is section 7.9, using trig ratios, sine and cosine. If you haven't watched 7.8 yet, you're going to need to do that because this is just a continuation of that learning. Okay, so let's look at what the sine and cosine ratios are after we learned about the tangent ratio. Let's remind ourselves that the tangent ratio of an angle is always the opposite side of a triangle over the adjacent. So there's always a ratio that never changes based on a specific angle measure for the two sides opposite and adjacent. Now, let's talk about sine and cosine. First thing I want to mention is that when we abbreviate sine, it looks like sin, and cosine is COS. Tangent was more obvious, I think. So sine and cosine of angle A. Well, we're going to use angle A as our reference angle. So let's label our triangle sides. Across from the right angle is the hypotenuse, always. Across from the reference angle is our opposite side, and the remaining side is adjacent. So what are the sine and cosine ratios? Well, sine, it still has the opposite side in the numerator, just like tangent does. It's the opposite side compared with the, not adjacent, because we already have that ratio, but the opposite side compared with the hypotenuse. So sine is opposite over hypotenuse. In this figure, opposite is BC's measure, right? And hypotenuse is BA's measure, or AB, you could call it either. And cosine will keep the hypotenuse in the denominator, but it will have a different numerator. So hypotenuse is in the denominator here. Adjacent will be in the numerator. So the cosine ratio is adjacent over hypotenuse, and our adjacent side in this picture is CA, and our hypotenuse is still BA. Okay, again, and this is all these ratios for this example right here are based on that reference angle A. So now what we have is we have three ratios. We have sine is opposite over hypotenuse. Cosine is always adjacent over hypotenuse. And tangent is always opposite over adjacent. Okay, so a mnemonic device, excuse me, a mnemonic device is one of those things maybe you perhaps know about, the one that people use to help them remember the Great Lakes. Have you ever done this one? The Great Lakes. Use the word homes. So Huron, Ontario, Michigan, Erie, and Superior. So those are the Great Lakes. Of course, you probably have also heard of Roy G. Biv, and Roy G. Biv is the way to remember the colors of the rainbow. Well, there's also a mnemonic device that is used to help us remember our trig ratios, and that phrase is SOHCAHTOA. SOHCAHTOA. Perhaps you've heard somebody say that before and you're like, what are they talking about? But SOHCAHTOA helps us remember that the S, the sine function or sine ratio, is the opposite side over the hypotenuse. So it's SOH, so, right? And then Ka tells us that the C is the cosine ratio, and AH we say right? So Ka, cosine is adjacent over hypotenuse. And then the tangent ratio we know is opposite over adjacent. So if we said this, OA, so TOA. So Ka, TOA. It just helps us remember which is which, because otherwise sometimes it's hard to remember. Now, if you just remember that sine is opposite over hypotenuse, that's great. If you just remember that cosine is adjacent over hypotenuse, great. But if you need this mnemonic device, it is there for you. Now, this is not all in your notes packet, but I just want to remind you that we did this in the tangent section of notes. I want to remind you that now we have sine and cosine ratios, again, that don't change as long as you have the same angle measurement in whatever size triangle. The sine and cosine ratios never change. So again, we can use proportions to solve for missing sides. If we took that reference angle right here, 37, and talked about the sine ratio instead of tangent, we would say the opposite side over the hypotenuse. So we do this number divided by this number, and this divided by this, and this divided by this, and we would again find that same equal ratio for the sine of 37. Okay, so let's find the sine ratio for a given angle and then the cosine. So we're going to do the sine ratio for angle U, and then we'll do the cosine for angle R. So in the first one, I'm going to say, well, here's angle U, it's my reference angle, and I'm going to label my sides. Across from the right angle is my hypotenuse. Across from the reference angle is the opposite side, and the remaining side is adjacent. So if I want to write the sine ratio for angle U, I'm going to write sine of U, and I know the sine ratio is opposite over hypotenuse. And again, you can either memorize that or you can use your mnemonic device is SO, right? SO, S-O-H. So the opposite side in this picture is 16, and the hypotenuse in this picture is 34. So the sine of U is 16 over 34. Now we'll do the cosine for angle R. Here's angle R, and we're going to find the cosine for that angle. And again, I'm going to label my sides first. Across from the right angle is my hypotenuse. Opposite of the reference angle, the angle we're referencing is the opposite, and then the remaining side is the adjacent. Again, notice it's a different setup than this one right here. So cosine. Well, cosine is the adjacent side over the hypotenuse. Ka, right? Ka. The adjacent side is 28, and the hypotenuse is 53. Okay, so let's make sure we understand how to use these ratios to solve problems. Now, here's the deal. Now we're not going to know, am I using tangent for this problem? Am I using cosine or am I using sine? Can we use a different theorem like a squared plus b squared equals c squared to find the missing side? Well, here's the missing side. We know the hypotenuse is 19, but we don't know this side here, so we can't use a squared plus b squared equals c squared. So instead, we're going to find the angle we know, and we're going to use that as our reference angle. We're going to label our sides, hypotenuse, opposite, and adjacent. We're going to see which ratio that helps us use, and then we're going to set up the proportion and solve. So here's 18. That's the angle measure I know. So based on that angle, I'm going to label my sides. This is the hypotenuse because it is across from the right angle. Opposite of my angle of reference is here, opposite, and the remaining side is adjacent. Now, the easiest thing I like to think about sometimes is if we, okay, back up 1 second, sorry. We're trying to find this side, right? It's x. So that's the opposite side. What's another side we know in this triangle? We know this side is 19, which is the hypotenuse. So the adjacent side is not involved here because we're not trying to find it and we don't know it. We're using the opposite and the hypotenuse. So if I go over here and I write, oops, so ka toa, there's two ways you can think about which ratio we need to use. Number one, you can think about which side we're trying to find and which side we already know. Or you can simply think about which side we're not going to have involved because it doesn't have a label. So the adjacent side doesn't have a label. We're not going to use adjacent. Which of these doesn't use adjacent? Well, sine. Sine uses opposite and hypotenuse. Well, we are trying to find the opposite, and we know the hypotenuse. So this is the trig ratio we are going to use in this problem because we're trying to find the opposite, and we know the hypotenuse. All right, so we write sine, because we're going to use the sine ratio, as we just determined, of 18, that's our angle of reference, is opposite side, which is x, over the hypotenuse, which is 19. And just like in the previous lesson, we're going to go ahead and create a proportion. We're going to cross multiply to solve the problem. X times 1 is x. Sine of 18 times 19. Again, is your calculator in the right mode? Let's check and see. So we do sine of 18. Now sine, you're looking for that SIN button. It looks like a sin button on your calculator. When you do sine of 18 times 19, you should get 5.871. Again, if you don't, your calculator is in the wrong mode. Take a look at videos or ask about how to change the mode in class. So we have now found the missing side length right here, 5.871. We know the side is 19 still. We could find this side now either using a trig ratio or by using a squared plus b squared equals c squared if we needed to find that side. But we don't. Let's carry on. Okay, a couple more examples. Let's take a look at the first one. Again, I would keep a consistent pattern of how you do these. That's the angle we know the measure of. So we're going to use that as our reference. We know the hypotenuse is always across from the right angle. Hopefully you're used to writing H for that. Opposite of the reference angle, we're going to put an O, and the remaining side is A. If we're trying to find X, that's the adjacent side. If we know this side is 30, that's the hypotenuse. Which trig ratio uses A and H? Well, that would be cosine, ka, right? So cosine of our 31-degree angle we're referencing is always the adjacent side over the hypotenuse. So X is our adjacent side, and our hypotenuse is 30. X times 1 is X. And then we're doing the cosine of 31 times 30. And we're going to find out that X is 25.715. Please round all answers to the thousandths place. The last example asks, if you walk from one corner of a basketball court to the opposite, how far have you walked? Okay, so we know this length is 94. We don't know this length, but we do know an angle measure. We're trying to find the hypotenuse. Let's take a look at how we would solve this. So we have our reference angle, 62. Our hypotenuse is across from our right angle, so that's this side. And again, I'm only looking at this triangle right here. Across or opposite the 62-degree angle is over here, which leaves this side to be the adjacent. Again, paying attention to what side we're trying to find. We're trying to find X, which is the hypotenuse. Which side do we know? Well, we know the length of the opposite. So which trig ratio uses O and H? O. So sine does. So we say sine, the sine ratio for the 62 degrees, sine of 62 equals the opposite side over the hypotenuse. The opposite side is 94. The hypotenuse is X. Now this is one that we have a little extra step in here when we solve, because when we cross multiply here, we get 94 times 1, which is 94. And then we have sine of 62 times X. So the sine of a 62-degree angle times X. Again, we did this in the tangent lesson. To solve this, these are being multiplied. We need to divide to solve. So I'm going to divide by sine of 62. These cancel, and we get X on the right equals 94 divided by the sine of 62. So 94 divided by sine 62, enter, and we get 106.462 when rounded appropriately. So that diagonal on the basketball court is 106.462 feet. And it makes sense that this is the longer side than this 94 here because it's the hypotenuse and it has to be the longest side. So something to keep in mind as you check your work.